40 years ago, satellites were built to find tanks. Today, they mostly find factories that don't look like factories, and military bases that don't look like much has changed at all. There's a strange image pattern that analysts at Maxar and Planet Labs have been quietly tracking since the early 2020s. On one side, sprawling logistics grids outside American forward bases in the Indo-Pacific, fuel depots, rotational troop housing, hardened aircraft shelters expanding in slow, expensive increments. On the other side, inland Chinese industrial clusters, fiber optic linked, fully electrified, often doubling output capacity in under a year, without the kind of visible militarized footprint we instinctively expect from a rising power. The unsettling part isn't what the satellites see, it's what they don't. And it forces a question most defense commentary avoids because it sounds too simple to survive contact with reality. What exactly are we measuring when we say power from orbit? Because if you strip away the language, satellites don't actually see armies or engineers. They see heat signatures, construction timelines, energy throughput, and land conversion rates. In other words, they see what a country chooses to build when nobody is supposed to be watching closely enough to matter. The United States still projects force through distributed military architecture. Diego Garcia, Guam, Darwin rotations, prepositioned stocks. It's a system designed around presence, deterrence, and rapid deployment. It is, in engineering terms, a logistics problem wrapped in geopolitics. China's system, especially after the 2015 military-civil fusion reforms under the Central Military Commission, leans in a different direction. Dual-use infrastructure is not an exception. It's the default assumption. High-speed rail corridors that double as troop movement networks. Coastal shipyards that pivot between container vessels and naval hulls depending on order flow. Civilian industrial zones that quietly absorb defense subcontracting without changing their external geometry. And here's where the satellite perspective becomes almost uncomfortable. Because from orbit, there is no ideological label attached to a structure. A runway is a runway. A steel plant is a steel plant. A port expansion is just geometry changing over time. Meaning has to be inferred. And inference is where most geopolitical narratives quietly begin to break. One detail from a 2023 CSIS satellite analysis sticks here. The report noted that several Chinese inland drone production clusters expanded floor space faster than some entire U.S. defense procurement cycles complete contracting reviews. Not production, just approvals. That gap matters more than it looks, because satellites compress time into visible change. And in that compression, bureaucratic speed becomes strategic visibility. We'll come back to that idea, because it quietly explains more than most military comparisons ever admit. But there's another layer underneath all of this that rarely gets discussed with any seriousness. It's not just that one system builds military capability through visible infrastructure and the other embeds it inside civilian networks. It's that each system is being read incorrectly by the other, because both are still partly optimized for an older world where war and production were physically separable. That world is gone, and the satellites know it before the policymakers fully do. Which raises a more uncomfortable thought. If both sides are visible from space, but only one side's visibility actually reflects its strategic intent cleanly, then what exactly is being misread, and at what cost? Because the next layer of this story isn't about satellites at all. It's about what happens when visibility stops being transparency and starts becoming misinterpretation. That CSIS observation I mentioned earlier, about production facilities expanding faster than procurement cycles, sounds abstract until you anchor it in a specific place. So take Chengdu's aerospace-adjacent manufacturing corridor in Sichuan province. Not the flashy coastal hubs like Shenzhen or Shanghai, but inland industrial zones that rarely show up in tourist footage or corporate promo reels. Between 2019 and 2024, satellite imagery tracked by commercial providers like Planet Labs showed something very specific. Repeated cycles of warehouse expansion, rooftop solar integration, rail spur extensions, and what analysts call modular factory segmentation. In plain terms, instead of building one giant facility, the area builds interchangeable production blocks that can be retasked without changing the outer footprint. Now compare that to a typical U.S. defense industrial expansion cycle. A new missile component line, say solid rocket motor expansion, moves through environmental review, congressional allocation, subcontracting allocation, and then phased construction. Even when funding is approved, physical expansion is often staggered across multiple fiscal years. The system is optimized for accountability, not speed. Neither system is irrational. They are just optimized for different historical threats. But satellites don't care about historical context. They only register delta over time. What changed, how fast, and how consistently. And in that metric, something subtle becomes visible. In China's case, industrial zones don't spike and then stabilize. They ratchet. Every cycle adds baseline capacity that rarely rolls back. Even when demand fluctuates, the infrastructure floor keeps rising. In the US case, expansion tends to be episodic. Funding spikes during geopolitical shocks, Ukraine war procurement waves, Indo-Pacific posture adjustments, but then plateaus or slows as political attention moves elsewhere. That difference creates a strange asymmetry from orbit. One system looks like it is constantly under quiet acceleration. The other looks like it is reacting in bursts. There's a phrase used inside defense logistics circles that captures this without intending to. Surge capacity versus sustained capacity. Surge capacity is what you build when you expect a crisis and want to win it quickly. Sustained capacity is what you build when you assume competition never stops. Now, here's where the story tightens. Because China's inland industrial clusters are not purely civilian, the 2015 military-civil fusion policy explicitly requires that new infrastructure meet dual-use standards. That doesn't mean every factory produces weapons. It means every factory is compatible with rapid reallocation if needed. A port that handles container shipping today can handle amphibious logistics tomorrow without reconstruction. A drone assembly line producing agricultural mapping systems can be retasked toward surveillance platforms with software and component swaps, not structural overhaul. That is the key distinction satellites indirectly expose. It's not that one country is building more military. It's that one country is building infrastructure that assumes reversibility between civilian and military output is normal. And then there's the human layer most satellite analysis quietly misses. In 2022, during power rationing events in parts of eastern China, some industrial parks didn't shut down entirely, they shifted load. Production lines were redistributed across provinces through rail-linked industrial coordination networks. It wasn't chaos, it was rerouting. Analysts who expected disruption instead saw continuity. Not perfect efficiency, but no collapse in baseline output. From orbit, that looks like something very specific, a system that treats strain as routing problem, not shutdown condition. Now compare that with what happens in the US system during stress events like supply chain shocks or defense production bottlenecks. You often see bottlenecks propagate into procurement delays, labor shortages, and contract renegotiations. The system absorbs shock through negotiation rather than rerouting. Again, neither is better in absolute terms. One prioritizes compliance and institutional oversight. The other prioritizes throughput under centralized coordination. But satellites compress all of that into one observable pattern: continuity versus interruption. And that brings us back to the original phrase, soldiers versus engineers, because that framing is slightly misleading. It assumes visibility equals intent. It assumes what we see from orbit maps cleanly onto doctrine. But what we're actually seeing is something more uncomfortable. We are watching two different interpretations of what it means to prepare for long-term competition, etched into concrete, steel, and rail lines across continents. And the question that starts to form, almost quietly, is whether the visible difference is actually about military philosophy at all, or about how each system treats time. Because once you start measuring time from space instead of power on paper, the comparison stops behaving the way most commentary expects. There's a risk in reading too much certainty into orbital imagery, because satellites are brutally honest about structure, but almost blind to stress. A factory can look perfectly synchronized from above, right up until the moment its supply chain fractures. A rail network can appear seamless until one choke point turns it into a bottleneck map. Even military posture can look stable until it suddenly isn't. This is where the comparison between American and Chinese systems gets more complicated than the engineers versus soldiers framing allows. Take something most people don't connect to satellite analysis: wartime logistics history. During the Korean War, U.S. forces demonstrated something that still defines their doctrine today: adaptive logistics under contested conditions. The ability to reroute supply chains across sea and air corridors in real time, even when infrastructure on the ground was partially degraded. That system evolved into what today's Pentagon calls distributed resilience, heavily reliant on allied bases and redundant transport layers. China's modern system, by contrast, has been optimized under almost opposite conditions: uninterrupted domestic industrial scaling, massive infrastructure build-out, and tightly coordinated provincial production networks operating under peacetime constraints. That difference matters more than it first appears, because satellite visibility rewards exactly what peacetime optimization produces: clean expansion lines, predictable throughput, measurable growth in physical infrastructure. But war doesn't behave like that. War introduces friction that doesn't show up in construction timelines. It introduces deception, disruption, energy denial, cyber interference, and most importantly, intentional collapse of predictability. And here's where the earlier ratcheting capacity idea hits a limit. A system designed to continuously expand efficiently may not automatically translate that efficiency into chaotic environments where expansion is not the dominant variable anymore. Survival of flow is. We've actually seen small previews of this in non-military disruptions. During COVID-era supply chain shocks, Chinese manufacturing initially maintained higher output continuity than many expected, but specific sectors, semiconductors, advanced lithography components, specialized machine tooling, experienced delayed feedback loops that exposed dependency chains outside domestic control. The system was strong, but it was also tightly interlocked. And interlocking is a double-edged design choice, because the more seamless a system looks from orbit, the more it depends on every link behaving normally. Now compare that with the American model again. Not as superior or inferior, but structurally different. The U.S. defense industrial base is messy, fragmented, redundant in places where it shouldn't be, and surprisingly fragile in others where it should be strong. But that fragmentation creates a different kind of resilience. Failure doesn't propagate evenly. It clusters, isolates, and sometimes gets absorbed without collapsing the entire chain. From a satellite perspective, that messiness often looks like inefficiency. But inefficiency is not always the same as weakness. Sometimes it's slack, and slack is what absorbs shock. There's a subtle irony here that analysts don't always say out loud. Systems that look most optimized from orbit are often the ones whose internal margins are thinnest. And systems that look disorganized often carry hidden buffers that only become visible under stress. This is where the earlier assumption, visibility equals clarity, starts to break. Because satellites are excellent at measuring construction velocity, land use change, and infrastructure density, they are not good at measuring bureaucratic friction, alliance depth, wartime adaptability, or institutional improvisation. Those variables only appear when something goes wrong. And nothing in orbital data predicts how a system behaves at the exact moment it stops behaving normally. Which brings us to the uncomfortable reversal in this entire comparison. What looked like a clean contrast, soldiers versus engineers, force projection versus industrial expansion, starts to blur once you ask a simpler question. Which system is optimized for being seen? And which system is optimized for surviving what cannot be seen? Because those are not the same thing. And satellites, for all their precision, only ever answer the first question cleanly. If you want to understand where this comparison actually lands, you have to stop looking at countries and start looking at decision loops. Not ideology, not hardware, not even budgets, just this: how many steps it takes for a decision made at the top to become physical change on the ground. In the United States defense ecosystem, that loop is long by design. A requirement gets generated by the Pentagon, filtered through the Joint Chiefs, converted into procurement language, reviewed by Congress, translated into contracting obligations, split across prime contractors like Lockheed Martin and Northrop Grumman, then diffused again into subcontractor networks spread across states that each have their own political incentives. It is not a broken system, it is a layered one. Every layer adds verification. Every verification adds delay. Every delay reduces catastrophic risk. Now look at China's industrial state interface. A directive from central planning bodies, whether through the National Development and Reform Commission or sector-specific industrial guidance, doesn't bypass structure, but it moves through fewer interpretive layers. Provincial governments compete to execute rather than reinterpret. State-owned enterprises and private contractors operate inside a narrower band of deviation tolerance. Again, this is not faster equals better. It is just structurally different compression of decision-to-action time. And satellites, indirectly, capture the result of that compression. Because what they see is not just factories or bases. They see how quickly intent becomes geography. There's a small, almost overlooked example of this from the mid-2020s expansion of China's inland drone manufacturing ecosystem. One facility in Anhui province, linked to multiple civilian logistics drone programs, was observed expanding production floor area in phased segments over roughly 14 months. But what analysts found more interesting wasn't the expansion itself. It was the synchronization of auxiliary infrastructure, housing blocks for workers, rail spur adjustments, and localized power grid reinforcement, all appearing within overlapping windows of construction. That kind of coordination doesn't require genius engineering. It requires synchronized permission systems. Now contrast that with a U.S. defense production bottleneck that became publicly visible around solid rocket motor supply chains. Multiple contractors reported capacity constraints not because of lack of industrial capability, but because scaling production required alignment across environmental approvals, workforce training pipelines, and multi-year contracting guarantees that could not be compressed without legislative action. The system worked, but it worked at institutional speed, not operational speed. And here is where the human anchor inside this story actually matters more than the infrastructure. Inside both systems, there are planners, engineers, logistics officers, procurement officials, people who are not thinking in grand strategy terms. They are thinking in constraints. Lead times, material availability, regulatory clearance, budget cycles. One engineer at a Chinese aerospace subcontractor described it in a way that quietly stuck with analysts who later reviewed industrial coordination data. We don't wait for perfect instructions. We work inside the direction already given. It sounds simple, but it reflects a deeper difference in how uncertainty is handled. In the U.S. model, uncertainty is absorbed through process expansion, more review, more oversight, more redundancy in approval chains. In the Chinese model, uncertainty is often absorbed through execution flexibility within a more narrowly defined directive space. From orbit, both systems can look efficient or inefficient, depending on what snapshot you choose. But over time, satellites reveal something more consistent. Not who builds more, but who changes direction more smoothly once the decision has already been made. And that brings us to a subtle complication in the soldiers versus engineers framing. Because soldiers are trained for rapid response under uncertainty, engineers are trained for precision under known constraints. But modern state systems don't fit neatly into either category anymore. They are hybrid machines that blend both logics, just in different proportions. So the real question isn't which system is more visible from space. It's which system converts its internal logic into external action with fewer translation losses when conditions stop behaving predictably. And that question doesn't resolve cleanly in satellite imagery at all. It only becomes visible when something forces both systems to leave peacetime logic behind and operate under stress that neither was originally designed to prefer.